Hello friends, how are you? Wait, this is not a video about the beam of the light as you are seeing in the background. This is about the structural beam. And in the previous videos, we have seen basics of the beams and solved some problems including inclined load, bracket load, nonlinear load. And now, in this video, we are going to solve the problems on compound beam with internal hinge. So, assume we have these two beams, and if they are connected by a pin, then this becomes a compound beam with internal hinge. So, what are the unknowns? What are the equations of equilibrium for this type of beam? And what is the shear at the pin? How to calculate this? We will solve in today's problem. So let's get started. Engineering Fundamentals. Guidance by Somayya sir, Pune, and I am Yugandhara Tadale. Content of the video is introduction, then beams, its definition. What is static determinacy of beams? Types of beams. Then some problems that will be with linear and non-linear loads. Problems on compound beams and problems on beams with internal hinge. Now we will see the problem on compound beam with internal hinge. Let's solve it. Concept for the compound beam with internal hinge. So here we have one extra moment equation per pin. That is, summation of moment at pin is equal to 0, and it will be by considering forces on any one side of the pin. We will see the application of this concept in the problem. Typical procedure to solve such types of problems is like this. First, you have to draw a structure F.B.D. That is, you have to show all the support reactions on the beam. Then apply equations of equilibrium and find support reactions. Then third is draw member F.B.Ds if pin reactions are required. So what is member F.B.D? We will see in the problem. When members are separated by removing pin, show two reactions, horizontal and vertical, equal and opposite on the respective members. Shear at pin is under root of h square plus v square. We will see how these steps are applied using the problem. So, in the problem, this is beam AB, BC and CD. And BC and CD are connected by a pin. Here, the unit system is foot and pound. The load of 120 lb is acting on BC at a distance of 1 feet from support B. AB is overhang of 2 feet length, and force of 40 lb is acting at the center of the member CD. Now, for the solution of these reactions, we have represented reactions at each type of the support. At support B, it is roller support, so vertical reaction perpendicular to the roller, and at support D, which is a fixed support, so there will be horizontal component HT, vertical component VD, and a moment which is assumed as anticlockwise is there. Next step is to apply equations of equilibrium to find out these support reactions. So first, summation of Fx gives us Hd is equal to 0, and summation of Fy, which is Vb minus 120 minus 40 plus Vd is equal to 0. And yes, it was according to the sign convention given here. As I have told you in the previous slide, we get one more moment equation per pin for the beam with internal pin. So here it will be applied as follows. So summation of moment at C, that is at pin on left hand side. So we will consider only A to C part of the beam. So there are only two forces. One is VB and other is 120 lb downward. So moment equation will be this VB 120 making a clockwise force. So it will be negative minus VB into 4, and this plus 120 which is making a anticlockwise couple. So 120 into 3 is equal to 0, which gives us VB is equal to 90 lb. Now we will take summation of moment at C on only right hand side of the beam. So VD into 2, it is a anticlockwise movement, so VD into 2, and this force 40, it is making a clockwise movement, so minus of 40 into this distance 1 and plus this MD is equal to 0. So we get VD is equal to 70 lb and MD is equal to negative of 100 foot-pound. So the reactions we got from the equilibrium equation and the extra moment equation for the pin we have shown in this diagram. But the value of MD we got as negative of 100 foot/pound. So the direction we assumed was incorrect. So we corrected it here. Now we want reactions at this pin. For that we will separate AC and the other element. So at pin there will be two reaction components, horizontal and vertical. By applying equations of equilibrium, that is summation of Fx and summation of Fy, we get Hc is equal to 0 and Vc is equal to 120 minus 90, that is equal to 30 lb. Now we will separate this CD from the pin. And according to the concept, the loads are shown as equal and opposite acting at the pin. So HC will be 0 in this direction and VB will be downward. VC will be downward of 30 lb. Now we will check by applying equations of equilibrium to this beam. So is it satisfying? Yes, horizontal forces sum is 0 as only HC is acting, and VC is equal to this 70 plus 70 VD minus 40, that is 30. It is equal and opposite to the previous beam, and a moment of 100 foot-pound is acting. Thank you so much to you all for being with me throughout this video. I'm grateful for your support. Happy learning! If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.